Imagine trying to explain the modern world without computers. No smartphones. No GPS. No digital cameras. No wireless communication as we know it. No modern synthetic fibers. No internet culture. No search engines. No AI. Now imagine that many of the ideas behind this world began not with giant corporations, but with individual people working with primitive equipment, incomplete theories, and almost no idea of what their discoveries would eventually become. A mathematician helped define what a computer could be before modern computers even existed. An engineer transformed radio communication. An entrepreneur turned photography from a complicated scientific process into something ordinary people could use. A chemist helped create synthetic materials that would reshape the modern world. A young programmer helped shape the architecture and philosophy of the open internet. A quiet programmer helped build the early Microsoft machine that would become one of the most powerful software companies in history. And a computer scientist created a website that taught millions of people how the technological world around them actually worked. 7 people, 7 very different contributions, and 7 lives that ended in tragedy. But this is not a story about death. It is a story about impact. Because when we look at technology today, we tend to see finished products. A smartphone, a computer, a radio, a camera, a fiber, a website, artificial intelligence. But behind every finished technology is a chain of ideas. And somewhere in that chain, there is usually a person who saw something before everyone else did. This is the story of 7 of those people. The bigger question: what does it actually mean to change the world? There is a problem with the way we tell the history of technology. We often remember products. We remember companies. We remember brands. But we forget the people who changed the underlying possibilities. Technology does not advance in a straight line. It advances when someone changes one of the rules. What if machines could calculate information? What if radio could reject static? What if photography could become simple enough for almost anyone? What if chemistry could manufacture materials that did not exist in nature? What if information on the internet could be distributed freely? What if software could become the foundation of an entirely new industry? What if complicated scientific ideas could be explained to ordinary people? Those questions lead us to 7 very different stories. And the deeper we look, the more interesting the pattern becomes. Because these were not simply inventors. They were system changers. Alan Turing, the man who helped define the computer. Before the smartphone. Before Windows. Before the internet. Before silicon chips became the foundation of civilization, there was a much more basic question. What is a computer? Helped answer it. His work was not simply about building a faster machine. It was about understanding computation itself. The idea behind the theoretical machine, now known as the Turing machine, became one of the foundations of computer science. During World War II, Turing's cryptanalytic work contributed to Britain's efforts against German encrypted communications. But his importance did not end when the war ended. At Britain's National Physical Laboratory, he worked on the ACE, an early detailed design for a stored program computer. Later at Manchester, he worked with Max Newman and helped lead work that produced the Manchester Mark I and eventually the Ferranti Mark I. And in 1950, he asked an even more radical question. Could a machine think? His proposed experiment became known as the Turing test. That question now sits at the center of the artificial intelligence revolution. In other words, when we debate whether today's machines are intelligent, we are still living inside a question Turing was asking more than 70 years ago. But the story of Turing also exposes something darker about technological history. In 1952, he was prosecuted in Britain because of his relationship with another man. He was given a choice between imprisonment and hormonal treatment. He chose the treatment. 2 years later, on June 8, 1954, Turing took his own life, according to GCHQ. The tragedy is not simply that a brilliant scientist died young. It is that a society capable of recognizing his extraordinary value could simultaneously punish him for who he was. And that gives us the first lesson of this story. A civilization can be technologically advanced and still fail the people who advance it. That is why Alan Turing deserves an entire episode of his own. Not simply because of Enigma, but because his work connects cryptography, computing, artificial intelligence, and the very definition of intelligence itself. The engineer who changed radio. Now move from mathematics to electricity. Imagine a world where radio exists, but static, interference, and noise constantly interfere with communication. Then one engineer decides that the problem is not the radio. The problem is the way the signal is being transmitted. His name was Edwin Howard Armstrong. Armstrong developed several fundamental technologies in radio engineering, including the regenerative receiver, the superheterodyne system, and eventually wideband FM. His contribution to radio was enormous. The superheterodyne principle became a fundamental architecture in radio receivers. And FM changed broadcasting by making radio much more resistant to static and interference. Columbia describes Armstrong's work as spanning regenerative, superregenerative, superheterodyne, and wideband FM systems. But Armstrong's story contains another dimension of technological history. Innovation is not always rewarded immediately. His inventions became entangled in patent disputes and conflicts with major corporations. RCA became one of his major adversaries. Armstrong spent years fighting over the rights to his technology. By the end of his life, these legal battles had consumed enormous amounts of time and energy. In 1954, Armstrong died by suicide after jumping from his New York apartment. Columbia records that his legal battles with corporations had plagued him for years. And that makes Armstrong fascinating for a technology documentary. Because his story is not simply, a man invented FM. It is, what happens when the inventor of a technology has to fight the system that wants to control it. That question is still relevant today. Patents, corporate power, ownership, licensing, inventors versus companies. Armstrong lived through an early version of a conflict that continues throughout Silicon Valley. The man who made photography ordinary. Today, billions of photographs are taken every day. Taking a picture requires almost no technical knowledge. Point, press, done. But photography was not always like that. When George Eastman became interested in photography, the process was cumbersome. Heavy equipment, glass plates, chemicals, tripods, special preparation. Photography was closer to laboratory work than everyday life. Eastman wanted to change that. He pursued dry plates, manufacturing systems, roll film, and eventually simple cameras. Kodak's own history describes his goal as making photography as convenient as a pencil. In 1888, Eastman introduced the Kodak camera. The concept was revolutionary. You take the picture, the company handles the complicated part. That was more than a camera. It was a new model of consumer technology. Hide the complexity. Simplify the interface. Make the technology accessible. That philosophy is everywhere today. Your smartphone contains billions of transistors and extraordinarily complicated software. But you do not need to understand any of it to take a photograph. Eastman helped establish that kind of relationship between people and technology more than a century ago. Kodak later became one of the defining names in photography and imaging. Eastman was also a major philanthropist, supporting education, science, music, and healthcare. But in his later years, he suffered from progressive disability. On March 14, 1932, at age 77, George Eastman died by suicide. Kodak's historical account states that his declining physical condition and frustration with losing his ability to maintain an active life contributed to his final years. And his story leaves us with another important idea. Sometimes the most revolutionary technology is not the one with the most complicated engineering. It is the one that makes complicated engineering disappear from the user's experience. The chemist who helped create a synthetic world. Now we leave electronics entirely. We enter chemistry. And we meet Wallace Hume Carothers. Carothers worked at DuPont during a period when scientists were beginning to understand polymers in a much deeper way. His work helped establish important theories about how polymers were formed. His research contributed to the development of neoprene. And then came nylon. Nylon became the world's first fully synthetic fiber and eventually transformed clothing, manufacturing, consumer goods, and wartime production. The American Chemical Society notes that Carothers' polymer research led to nylon and neoprene, and that his materials remained important commercially long after his death. But Carothers never experienced the full impact of nylon. He died in 1937 before the public announcement and commercialization of the material. His scientific career had been extraordinarily productive, but he also struggled with depression. In April 1937, Carothers took his own life. That timing is almost impossible to comprehend. The scientist was gone before the world fully understood what his work would become. Nylon would later appear in clothing, industrial products, military equipment, and parachutes. His chemistry became part of the physical infrastructure of modern life. And that reveals something important. An inventor may never see the world created by his invention. The consequences of scientific work can outlive the scientist by decades, sometimes by centuries. A pattern is starting to appear. 4 stories. 4 completely different technologies. Computing, radio, photography, synthetic materials. And yet they share something. None of these inventions existed in isolation. Turing changed the theoretical boundaries of computation. Armstrong changed how information could travel through radio. Eastman changed how humans could capture information visually. Carothers changed what physical materials humans could manufacture. Different fields, different problems, but the same underlying process. Take something difficult and expand what humans are capable of doing. And now we enter the digital age. The young programmer who challenged the information system. Aaron Swartz belonged to a completely different generation. He grew up with computers and networks. For him, information did not have to live inside physical books or laboratories. It could move instantly across borders, across networks, And he believed that access to knowledge was one of the great possibilities of the Internet. Schwartz contributed to the development of RSS and worked on technologies and projects connected to the emerging web. He was also involved with Creative Commons and Reddit, and became an important voice in debates over open access and the future of information. His importance was not simply technical. It was philosophical. He asked, if humanity has created a network capable of distributing knowledge almost instantly, who should control that knowledge? That question became increasingly important as academic research, software, journalism, and culture moved online. His confrontation with the legal system over downloading millions of academic articles from JSTOR became a major controversy. MIT later conducted an internal review of its role in the case after Schwartz's death. MIT described him as a young programmer and internet activist and noted that he died by suicide in January 2013. He was only 26, and his story represents a new kind of technological conflict. Turing asked, "What can machines do?" Armstrong asked, "How can information travel better?" Eastman asked, "How can ordinary people capture information?" Schwartz asked, "Who gets access to information once technology makes distribution almost unlimited?" That is why his story belongs in this series. The forgotten programmer behind early Microsoft. Now we arrive at one of the least famous names on this list. And that is exactly why his story matters. You know Microsoft. You know Bill Gates. You know Paul Allen. But there was another person in the earliest days of the company. Rick Weiland. Weiland was a software developer and programmer who became the second employee of Microsoft. He had known Paul Allen since school, and he was part of the early programming environment that helped shape the company before Microsoft became the global software giant we know today. This is a different kind of technological importance. Not every person who changes technology becomes a household name. Some people are infrastructure. They write code. They solve problems. They build systems. They work behind the famous founders. And then history remembers the company more than the people who built it. Weiland eventually left Microsoft and focused on investment and philanthropy. His later life included substantial charitable giving. In 2006, he died by suicide. His story is therefore useful not because he single-handedly created Microsoft. He did not. It is useful because it reminds us that technological revolutions are rarely the work of one famous genius. They are ecosystems, teams, programmers, engineers, designers, managers, people whose names disappear while their code becomes part of history. The man who taught the internet how things work. Our final story brings us almost to the present. Marshall Brain did something that sounds simple. He explained things. But that became extraordinarily powerful. In 1998, Brain founded How Stuff Works as a hobby project designed to explain complicated subjects in ways ordinary people could understand. The site grew into a major educational technology platform. How Stuff Works eventually became one of the recognizable names on the early educational web. Its founder combined computer science, engineering, writing, entrepreneurship, and science communication. This may not sound like an invention in the traditional sense, but it represents another revolution. The democratization of technical knowledge. The first technological revolution gave humanity machines. The internet gave humanity access to information. Websites like How Stuff Works helped people understand that information. And that matters, because technology only transforms society when people can actually understand and use it. Brain spent years teaching students and encouraging engineering entrepreneurship at North Carolina State University. In November 2024, he died by suicide. Contemporary reporting, based on his death certificate, confirmed the cause of death. His final hours followed a dispute at NC State that he described in an email to colleagues, although his allegations about university retaliation should be treated as his account rather than as an independently established cause of his death. His story brings our timeline almost all the way to the present. From Turing's theoretical machines, to Armstrong's radio, to Eastman's cameras, to Carather's polymers, to Schwarz's internet, to Microsoft's early software, to Brain's educational web. What do these 7 stories actually tell? At first glance, these stories seem unrelated. A mathematician, a radio engineer, a photographer and industrialist, a chemist, an internet programmer, a Microsoft programmer, a technology educator. But look at what each one changed. Turing changed computation. He helped define what it means for a machine to process information. Armstrong changed communication. He transformed the way radio signals could be transmitted and received. Eastman changed imaging. He turned photography into a mass consumer technology. Carather's changed materials. He helped create synthetic materials that became part of modern industrial civilization. Schwarz changed the information culture of the internet. He challenged assumptions about who should have access to digital knowledge. Weiland represents the software revolution. He was part of the small group of programmers working inside Microsoft's earliest chapter. Brain changed technological literacy. He helped millions of ordinary people understand complex systems. And that gives us a much more interesting definition of technological progress. Technology is not just about invention. It is about expansion. Expanding what machines can calculate. Expanding how far information can travel. Expanding who can take photographs. Expanding what materials humans can manufacture. Expanding who can access knowledge. Expanding who can build software. Expanding who can understand technology. That is the real connection between these 7 lives. The darker question. But there is one question we should be careful with. Did technology destroy these people? The answer is, we cannot responsibly say that. Their lives were extraordinarily different. Turing faced persecution because of the laws and attitudes of his time. Armstrong experienced years of professional and legal conflict. Eastman faced severe physical decline. Carather's struggled with depression. Schwarz faced enormous legal pressure and controversy. Weiland's life had its own personal circumstances. Brain's final period involved a serious workplace dispute. There is no single explanation. And turning all 7 stories into a simple formula, genius plus technology equals tragedy, would be bad history. The more interesting question is different. Why do societies sometimes recognize extraordinary talent while failing to protect, understand, or properly support the human beings behind it? That question is bigger than technology. And it is still relevant. The legacy. There is something almost strange about technological history. The people disappear. The technology remains. You can no longer meet Turing. But computers are everywhere. Armstrong is gone. But FM radio remains. Eastman is gone, but cameras are now in almost everyone's pocket. Carruthers is gone, but synthetic polymers surround modern life. Swartz is gone, but the battle over digital information is still happening. Weiland is gone, but Microsoft became one of the defining software companies of the modern era. Brain is gone, but millions of people still learn how technology works through the educational model he helped popularize. Their lives ended. Their ideas did not. And perhaps that is the most important lesson. A technological invention is not finished when the inventor dies. Sometimes that is when its real history begins. And this is where our story really begins. Because every one of these people deserves more than a few minutes. Alan Turing deserves an entire investigation into the machine that changed computing and the secret war that made him famous. Edwin Armstrong deserves a full story about FM radio, RCA, patents, corporate power, and one of the ugliest battles in the history of broadcasting. George Eastman deserves a story about how Kodak transformed photography and why the company eventually became a symbol of technological disruption. Wallace Carruthers deserves a story about the science of polymers, DuPont, nylon, and the creation of a synthetic world. Aaron Swartz deserves a story about the birth of the open web, RSS, Reddit, Creative Commons, JSTOR, and the battle over digital knowledge. Rick Weiland deserves a closer look at the forgotten programmers behind Microsoft's earliest years. And Marshall Brain deserves a modern story about how one engineer turned the internet into a giant classroom. 7 people, 7 technologies, 7 different revolutions. And behind every revolution, there was a human being. Final narration. We often tell the history of technology as if it were inevitable. As if computers were always going to appear. As if smartphones were always going to exist. As if the internet was destined to connect the world. It wasn't. The modern world was built by people making decisions. People taking risks. People solving problems that had never been solved before. People sometimes seeing the future before everyone else could see it. And sometimes people paid an extraordinary personal price. But their greatest legacy is not how their stories ended. It is what their work made possible afterward. Because every time we turn on a computer, listen to a radio, take a photograph, wear synthetic fiber, access information online, run software, or learn how a machine works, we are living inside a world shaped by people whose names most of us never think about. This is their story. And this is only the beginning. In the next episode, we go back to the beginning of the computer age and meet the man who helped teach machines how to think. Alan Turing.